carefully sketch the function y equals 2 plus 2 times the cosine of x minus 3 pi over 2 on 0 is less than or equal to x is less than or equal to 2 pi. The horizontal axis has already been defined here. So we know that it will run from 0 to 2 pi. So we can label pi here. Double that takes you to about right here. That's 2 pi. You could even put in some breakpoints here. There's pi over 2. And here is 3 pi over 2. 0 is here. So now we have the x range set. And to figure out what the y range should be for the axis that we're going to draw right here, it's worthwhile thinking about how large and how small each of these can be. Let's take a look at, first of all, the cosine of any angle. Well, the cosine of any angle is going to lie on the closed interval -1, 1. Which means when you multiply that function by 2, now this right here can fall anywhere between -2 and +2. You can see that this 2 term here is serving as an amplitude. Finally, when we add 2 to anything that's lying between -2 and +2, that entire thing there is going to lie somewhere between 0 and 4. So when we draw our vertical axis, which will start right here, we want to set the scale so that it tops out here at 4. So we can break it off this way. Now the next step is to plot the function itself, and the function itself is 2 plus 2 times the cosine of x minus 3 pi over 2. You could do this by plotting individual points, but I think you can do it a little more quickly in the following fashion. One angle x, which is going to be very easy to evaluate, is x equals 3 pi over 2. So plugging in x equals 3 pi over 2, we have 3 pi over 2 minus 3 pi over 2. That's 0. The cosine of 0 is equal to 1. 2 times 1 is 2, and then 2 plus 2 is 4. So at this point right here, we know at 3 pi over 2, the function is at 4. Now, what this term right here is serving as is it's serving as a horizontal shift. And the cosine function, which usually starts up at 1 at x equals 0, with all of the shift, is now going to start at 1 at 3 pi over 2. So if you just draw the cosine function here, and it'll make it down to 2 right there, and then do the same thing in the opposite direction, and that is here it has made it down to 2, and here it'll make it down to 0, and then back up to 2. That right there is a reasonable approximation of what this function right here is doing. Now keep in mind, it has been stretched using the amplitude of 2. It has been shifted upwards by 2. And in addition, the cosine function has been shifted to the right by 3 pi over 2 units. And that's how you come up with this smooth curve representing that function.